watched a lot of space movies that show that people age differently when they are in space. This is very true. For example, Sergei Kekalev, the longest person to be in space, he is 0.02 seconds younger than he is compared if he stay on Earth. So, how does this time dilation occur?
This whole relativity thing is quite complicated, but let's make it simple. Now, imagine you're in a high-speed spaceship shooting laser at your friend. The distance you and your friend is, for example, 3 meters, and you see that the laser just travels straight to your friend, which means that the ball travels 3 meters. However, that's from the astronaut's frame of reference. From an observer's frame of reference, it's a different situation. As the laser reaches your friend, the spaceship has moved 4 meters, and by using Pythagorean formula, and you will find out that the ball travels diagonally 5 meters.
Let's put that into numbers. The spaceship travels at the speed of light. If time is equal to distance over velocity, then for the astronaut, the time is gonna be equals to 3 over the speed of light. And then for the observers, the time is gonna be equals to 5 over the speed of light. The time is actually slower by a factor of 3 over 5. So let's put a simple number for the speed of light just to see the difference. Alright? Okay, let's put 5 for the speed of light. That means for every second that has passed for the observer, only 0.6 seconds has passed for the astronaut in the spaceship. And there you go, time dilation.
Apart from that, we can also see scenes in sci-fi movie where they get stretched or squished when traveling in spaceship. In science, this phenomena is called length contraction, or some people call it space contractions. Is this actually possible? Let's hear what they're gonna say.
Okay, remember now that there can be 2 different times at one same moment. Now imagine a spaceship traveling to a distant planet at half the speed of light. When the astronaut reaches there, he looked at his clock and found out that his journey only took 10 hours. But people from the mission control, his journey took 9 hours. But both agree that he's flying at the same speed. If distance is velocity multiplied by time, then there will be 2 different distances. Boom! The space has been contracted. For the mission control, they can see that the spaceship is squished.
In this universe, there are these particles called muons, which travels from space as a result of decay from the dangerous rays from the sun, and because of that they're traveling in the speed of light, and their lifetime is very short, which is 2.2 microseconds. After that, they'll decay into other particles. If they start from 5,000 meters, if they start to fall from 5,000 meters from Earth, they are not going to make it, since they can only travel 660 meters. But scientists actually can detect them from Earth. Why? Let's see from their perspective. Muons are traveling very fast, and because of that, their time is much more longer, and because of that, everything around them that they see, the Earth, are squished. So that's what enables them to reach Earth.
Now, the ultimate problem to space travel is the energy needed to travel to distant galaxies. In popular culture, we see spaceships shooting out of bluish plasma stuff, or they call accelerated electron, to fly. How far are we getting near to that kind of technology? Well, all of this comes back to mass energy equivalent. But what is mass energy equivalence?
The mass energy equivalent, or the E equals mc squared, means that mass is just a bunch of energy compacted into a small space. If an object is heated, the mass of the object actually increases because the heat energy is added to the total energy of the object. So, what does that have to do with space travel?
A space shuttle carries 500,000 kilograms of fuel and releases 213 billion joules of energy during the launch. And put that equals to E equals to mc squared, and you will get that the mass is only less than a kilogram, and compare that to 500,000 kilograms of fuel, that is so inefficient. And that is why scientists today are trying to find ways to produce energy which is more efficiently. Maybe 100% of mass can be converted into energy. It's like antimatter perhaps.
Wow, there's a lot of relativity things in space travel. With all the space mission, why is it so important, Boy? What are the impacts to the world?
We can clearly see the impact of space travel, especially to technology. For your information, a lot of technology today was born from space missions. Did you know that the technology in Hubble Space Telescope is used in digital mammography for breast cancer? Liquid-cooled garments during Apollo mission is used in race car driver and firefighters. And there are many other technological advancements, especially in computers. Space missions also benefit the environment. With all the satellites launched, we can monitor crops and scan the sea for oil. We can predict the weather and plan ahead. How about the society? Well, all the space missions have significantly enhanced our understanding about space. Other than that, space missions can tighten the bonds between nations because most space missions are developed together by multiple nations. Isn't that going towards global peace? Also, space missions have provided jobs to thousands of scientists and engineers around the world.
Now that we understand space travel and relativity, we can see that it benefits us and future generations. We can arrange the perfect time to travel to space, plan the energy needed, prepare the energy source, and many other reasons. I guess that's all from us. See you again.